recall that I'm finding the derivative. We call it y prime, or f prime of x, or dy dx. Okay? That's what we call it. Therefore, when we solve for the derivative, the solution is always stated as y prime equals, or f prime of x equals, or dy dx equals. This shouldn't be confusing to you. Okay? If they're asking for the derivative, which is one of these, then you say, well, this equals, or this equals, or this equals. It's fine. So, how do we do this implicit differentiation? We take derivatives of x's and y's. Alright? And we do it like this. We take the derivative of y just like it's an x. Okay? Except we place a dy dx right next to every y term when you take the derivative. Alright? And if that's confusing you now the way it's worded, I'll show you an example. Okay? Now remember, I said it could be dy dx. You could say y prime here as well. You probably wouldn't want to use f prime of x, and I'll show you why in a second. But once we do that, we then solve for dy dx. Right? And dy dx becomes the variable that you're solving for, basically. Alright? So you take the derivative of anything with an x, just like we normally do. There happens to be y's in there. We take the derivative of y's, and next to each y, when we take the derivative of it, we're going to put a dy dx next to it. And then we just solve for those dy dx's. Okay? For example, you've been doing this the whole time, you just haven't known. Just like the chain rule I said with the 1 with the x. If I wanted you to find y equals x squared, the derivative of this, what is that? 2x. It's actually 2x, isn't it? But when I take the derivative of this, I also take the derivative of that. That's 1, right? The derivative of x would be 1. The derivative of y is 1. But anytime we take the derivative of y, we also put a dy dx next to it. So every time the y is alone, it just goes away and becomes dy dx. Because I haven't been explained why until this point. Why? No. Never. Alright, so we're going to do stuff like that. And let's give it a try. Alright, find dy dx if y squared equals x. So we have y squared equals x. Alright? Correct. I'm going to take the derivative of every variable just like it would be an x. The derivative of y squared would be what? 2y. But when we take the derivative of y, we want to put right next to it dy dx. Like multiplying by, okay? Equals, the derivative of x is 1. Now I've got to solve that for dy dx. What do I got to do? Divide both sides by 2i. If I divide both sides by 2i, this goes away on this side. And there you go. 1 over 2y equals dy dx. Now, I said before, instead of using dy dx, because I like to write as little as possible, you can use the y prime symbol. So be careful, because if I were to solve this, I'm going to do this again. Over here. I would say this is 2y prime equals x. You can see where the... Yeah, people might think that's y to the first, or whatever. Technically, it's y prime, right? It's dy dx. So maybe if you want to write y like this, then all your y's like that. You know what I mean? Something to make it easier to see. I don't want you guys to confuse it otherwise. So that's why most people use dy dx. Some people just use y prime. But it can be confusing. Yeah, you don't want to start putting f prime of x's in there. It'd be crazy. Okay? Example 2 says, find the slope of the circle. X squared plus y squared equals 25. At the points 3, negative 4. So we know what it says slope, it really means derivative. So, what is the derivative of x squared? 2x plus, what's the derivative of y squared? 2y times, right, dy dx. You need to put that next to every y derivative you take. Equals, what's the derivative of 25? 0. Don't forget, you still need the derivative of this. You can't just set it equal to 25. You still take the derivative of a number. The derivative of any constant is 0. Okay? Now let's solve this for dy dx. What's the first thing you would do? Right. Sometimes people look at this and get confused. But you've got to look at this like this is the variable you're solving for. Start peeling everything away from it. Well, it's reverse PEMDAS, isn't it?
Wait.
Next to the y, not next to the x, only the y. Okay? So the first thing I'm going to do is subtract 2x. So I've got 2y dy dx equals negative 2x. Now what do? Divide by what? Divide by 2y. Divide by 2y. So I'm going to say my dy dx equals, what does that simplify out to be? Right. This 2 cancels with this 2, it leaves a negative 1 on top. So it's negative x over y. Am I done?
No.
They want it at what point? This is the x, and now we can plug in a y as well, because in our derivative we have an x and a y variable, don't we? So we just plug in equals, my x is 3 and my y is 4. So my x is 3 and my y is 4. And we get that from the coordinate right up there. Well, it's negative 4. 3, negative 4. Because that's the point they wanted at. You don't know if you would have caught it. Bang. So, that's negative 3 over negative 4 for y, which is 3/4. My slope of that circle, right at the point 3 comma negative 4, is 3/4. If you was up 3 over 4, up 3 over 4. The tangent line, right at that point. So it's not too crazy. So, all right, let's take a look at this next one. Example 3. 2y equals x squared plus sine of y. Find y prime. Okay. What's the derivative of 2y? It would be 2, right? Like if that was an x, that would be 2, but it's a y, so it's 2, and because it's the derivative of y, dy dx. I'm going to do this. I'm going to put a y prime here, just so you guys can see more with the y prime. It's not different, it's just a different symbol. That's fine. If you have dy dx right there, keep on doing it. What's the derivative of my next term? X squared. 2x plus, what's the derivative of sine? It's cosine. But in this case, it'd be the cosine of y times dy dx. Or in my case, I'm doing this y prime thing. I've got to solve for y prime, like it's my variable. Here's where people either get it right away or have to look at it for a second. In order to get y prime alone, because it's attached to 2 things, I need to get everything with y prime on one side and then factor it out. Then get everything else back home. Okay, yeah. So, what I will do is this. I will subtract the cosine of y times y prime from this side. And subtract the cosine of y times y prime on this side. And let's see what magic unfolds. We have 2y prime minus the cosine of y times y prime equals 2x. Now I can factor that out, can't I? I can factor that out, absolutely. Absolutely. So, I factor out my y prime, and what's left in the parentheses? 2 minus cosine of y equals 2x. And what's the last thing I do to get y prime alone? I divide. Yeah. If I'm multiplying y prime by 2 minus cosine of y, I'm going to divide by 2 minus cosine of y. So, divide by 2 minus the cosine of y. Divide by 2 minus the cosine of y. So my y prime equals 2x over 2 minus cos of y. That is it. That is great. That is done. Here we go. Example 4. Example 4. It says, find the tangents and normal to the ellipse x squared minus xy plus y squared equals 7 at the point -1, 2. So what is our goal ultimately? Forget about trying to do it. What do we need to do? Don't give me the specifics on how we're going to do it. Just what do we need to do? Alex. I need to find the derivative at that point exactly. We need to find the derivative at this point, which means I got to take the implicit derivative here of our equation. And once I do that, what do I do?
Put it in the y minus the y.
Yeah, I put it in our equation of a line. That's exactly what we do. So here's the let's go. Let's forget the kicker. Let's just go. What's the derivative of x squared? Okay, it is 2x. Now, yeah. What is xy? Anyone have any idea how we do xy?
1.
Wait, stop it.
It would be because derivative both those is 1, and you're multiplying 1 by itself, that'd be 1, and you have to put the dy dx.
No, but I like the word you said multiply in there, because you realize everything multiplied. So what rule do we use?
Product rule?
We got to use the product rule. First times derivative of second plus second times derivative of first. U times v prime plus v times u prime. Wait, no, that's low d high. Let's go. No. So I'm going to consider that instead of taking the derivative of x, y together, then distributing a negative in there, I'm just going to take the derivative of negative x with the y, and what it is what it is. Okay. So negative x, y. Okay. It is the first times the derivative of the second plus the second times the derivative of the first. So it's the first minus x times the derivative of the second. What is the derivative of y?
Y.
It's 1.
DXY.
1 then dy dx. You want me to go back to dy dx's?
Yes.
Dy dx plus the second, which is y, times the derivative of the first. What's the derivative of negative x? Negative 1. So ultimately, right after this 2x, I've got negative x dy dx minus y, right? It's positive y times the negative 1. So that's minus y. Now what's the derivative of y squared? So it's plus 2 what? 2y. You keep the y. Like if that was x squared, it would be 2x. Do the same thing, it's 2y. So since it's y, you can slap a dy dx after it. 2y dy dx equals what? 0. Don't forget, it's not 7, it's the derivative of 7. The derivative of any constant is 0. Now, if we have 2 dy dx's, what do I want to do in order to get it alone? Yeah, I want to get all my dy dx's to one side, factor it out, then divide by what's left. You see what I'm saying? So, let's do this. Let's add an x dy dx, and let's subtract a 2y dy dx from both sides. There's my split. Oh gosh, plus x. You see why I like to do y prime sometimes instead of dy dx? Dy dx and minus 2y dy dx. What did I lose? How?
just trying to get them alone.
We need to get these dy dx's alone. So I've got to get anything with a dy dx on one side by themselves. Because once I do that, I can factor it out and put everything back over. That's the whole key. Okay? So I have left here my 2x, because this cancels. I have my minus y, because this cancels. Equals x dy dx minus 2y dy dx. Now what do? I factor it out. This is the brunt of the work. And it's all algebra. It's all algebra. Okay? It is not too much, right? 2x minus y equals x minus 2. And I pull out that dy dx. 2y. Oh, indeed. It's right there. Right in your face.
2y.
Oh, you almost got it.
Close.
All right, now what do? Yeah, go ahead, say it. Divide by x minus 2y. This goes away, and now I have dy dx on this side, but I also have to divide by x minus 2y. Oh. Wait. Okay, so I have 2x minus y is x minus 2y. What's the coordinate they give us? At what point do they want the slope? That's the slope. So this is at the point -1 and 2. So that's my x and that's my y. So it is 2 times -1 minus 2 all over -1 minus 2 times 2. Does that look right?
And it's has to give
Huh?
us sub-0.
Yes, that looks correct.
Does it? What do you guys get?
0.
No? Oh, shoot.
5.
It's -4 over -5. Which is close this.
This is -2 minus 2.
Oh, yeah.
And this is -1 minus 4. So that is -4. You guys. So the slope, oh my goodness. Look at all that work we did. That is the slope right at point -1, 2. And not that I don't trust you guys, but I've actually done this before. Let me make sure that point is correct, and it is.
Right.
Yeah, when you guys master this, I'll teach you a shortcut.
All right. Shortcut?
No.
Right.
All right. My equation of a line.
Oh, I'm from space. I'm out of space.
All right, get creative. Small problem. I bet you can handle it all by yourself. You don't need your teacher to hold your hand and solve your problem. There's no space in paper. I wish the teacher didn't have to give you paper and you could write it all yourself, but the teacher does. Yeah. One more. Yeah. I know it is. I know it does. Okay, so let's go this. Y minus, what's my y? 2 equals the slope times x minus a -1. We subtract the negative?
Plus.
That is the tangent line.
Why are you doing?
What about the normal line?
Oh my gosh, for real?
You just put the slope in.
It's just the negative reciprocal. That is the perpendicular slope. We learned this already. In ninth grade, we did it a couple of notes ago. All right? It is y minus 2 equals -5/4 x plus 1. And why do we do that? Because despite all this work to find the slope, they just wanted the equations of both of those lines. And we couldn't get them until we got the slope. And we did. Example 5. Example 5. 2x cubed minus 3y squared equals 8. Find the second derivative, which means you got to find the first and then find the second. So, what's the derivative of 2x cubed?
6x squared.
6x squared minus, what is the derivative of 3y squared?
It is 6y prime.
6y, and then I'm going to put a y prime here, absolutely. Equals, what's the derivative of 8?
0.
I got to get y prime alone because I got to solve for y prime.
Don't you have to do second derivatives?
What do I got to get y prime? I haven't found the first derivative yet. I haven't gotten y prime alone. Okay, what do I do there? Let's add, well, you could have subtracted 6x squared and gotten the same thing. Okay, so if I add, I just like working with positives. Gone. 6x squared equals 6y times y prime. Now, how do I get y prime alone? Divide by 6y. Okay, this goes away, and my y prime equals. Will these cancel?
Sure.
So we can say x squared over y.
Okay.
That's the first derivative. That's the first derivative. Okay, so now we're going to use this to find the second derivative. Okay? So now I'll rewrite it all over here. I have y prime equals x squared over y. Now I need to use my quotient rule. Low d high minus high d low for all line squared over y. Okay? So it's low. Wait, first this is the high, in case you forgot, that's the low. It's low d high, so it's y times the derivative
2x.
of x squared, which is 2x, minus high, which is x squared, d low.
Which is d.
It's just 1, right? But then you put dy dx or y prime, whatever you use. So now look, that's y. I can't make that double prime. The derivative of y is still just y prime. The derivative of x squared is 2x. So this is just y prime all over I square below, right? All right. Now this is what I'm going to do. For the sake of ease, I'm going to break that up into two separate fractions. Okay? I've got... Would that be harder for you guys? Okay. I've got 2xy, that's what I get when I multiply these, over y squared, minus x squared over y squared, but this side is times y prime, right? I still have my times y prime on the right side.
Yeah.
Well, what can I do on the left side? What can I simplify here? One of these y's cancels one of these, right? That's all I can really simplify. So how do I get second derivative? That is my second derivative, but I got to get rid of that y prime. It's a good thing we know what y prime equals.
Okay.
I'm going to take this, because this is what y prime equals, and I'm going to substitute right in for y prime that.
Oh my god, I see.
Thank you. 2x over y minus x squared over y squared times, what is y prime? It is x squared over y. What do I get when I multiply these two together? All right, that's very good. I get 2xy, this side isn't changed, minus. Multiply those two, I do get x to the fourth. What do I get when I multiply these two? And that's is y double prime right there. So you always have to put, you're going to get to a point where you've got to substitute y prime back in for y double prime. Okay? Okay?
Alright, we're done.
So you guys can go home and try number 6 on your own.